Hello, in this video I'm going to be going over manometers, open and closed. First of all, what is a manometer? A manometer is a unit that measures the pressure of a gas in a closed chamber. There are closed and open, and what we're going to be doing first is a closed manometer problem. And these guys are easier than the open ones, and you'll soon find out. So a closed manometer is filled with mercury and attached to a container of helium. The difference in height of mercury between the two arms is 521 millimeters. What is the pressure of the helium in torr? So what I do is I draw a little picture of a manometer. What we got right here is the gas chamber. Here's the manometer. We have right here is, and this is closed, so the atmosphere has no impact on it. And it says the difference in height of mercury between the two arms, because there's mercury in here, is 521. Millimeters of mercury, so really that's our pressure. It's just the difference between the height on this left side and the height of this right side part, the arm. That difference in height is our pressure, basically, in mercury. But what is it in torr? Well, we got to convert it. And remember, there's 1 atm is equivalent to 101.3 kPa, which is equivalent to 760 mmHg, which is the same thing as 760 torr. So you can use any of those numbers in your conversion factor. I'm going to multiply it by 760 torr, because that's what I want to convert to. And I divide it by 760 mmHg, because that's what I'm getting rid of. And really, it's like multiplying it by 1, so it doesn't really change my number, but it does change my unit from mmHg to torr. That would be my answer. So my pressure in this case is 521 torr for my gas in that closed manometer. But what if we want to do something a little more difficult, such as an open manometer? A nice little picture of an open manometer. Move it over here. Oh, there's an open manometer. Difference is this guy is open to the atmosphere, so therefore the atmospheric pressure is going to have a direct impact on our gas pressure. So it says an open manometer, let's do number 2, is filled with mercury and connected to a container of hydrogen gas. The mercury level is 57 millimeters higher in the arm of the tube connected to hydrogen. The atmospheric pressure is 0.985 atm. What is the pressure of the hydrogen gas in atmospheres? Alright, again, I always start by drawing my little manometer. It's open, and here's my gas. And it says it's 57 millimeters higher in the arm of the tube connected to the hydrogen. So it's higher in the arm connected to my gas, my hydrogen. And it's 57 millimeters of mercury. Alright. If the atmospheric pressure is 0.985 atm, that's the pressure going down on it. I got to think, alright, which one is higher? My pressure in the atmosphere or my pressure in this gas chamber? So basically it's a tug of war. Whichever one is pushing down further is stronger. So in this case, the atmosphere is pushing down on this guy a lot stronger. So therefore, my atmospheric pressure is going to be higher than the pressure in my gas chamber, which means I'm going to subtract my difference in my pressure. If the gas was being pushed down more, then that would mean my gas pressure is higher, and I would add my difference in pressure. And that's really the trickiest thing. But before I do that, I need to convert into atm. So 1 atm goes on top, and 760 mmHg goes on the bottom. For this one, I'm going to need my calculator that I bring to class every day. Type in 57 times 1 divided by 760. Gives me 0.075. atm. Yep. So I'm going to subtract 0.075 atm. 0.985 minus 0.075. gives me 0.91. Is the pressure of my gas. So again, just recapping, what I did was I found that the mercury was higher in the gas chamber side than in the atmosphere side. Therefore, the atmosphere pressure was pushing down harder, meaning it was stronger pressure in the atmosphere, which means my gas pressure had to be lower. So I subtracted. If it was the other way around, drawing a picture of that, where it is higher on the atmosphere side, that would mean that my atmospheric pressure is not as strong, it's going to be lower than what my gas chamber pressure is. So therefore I would take my atmospheric pressure and my difference in mercury and add them together to have it equal a higher pressure in this gas chamber. And that is how you do open and closed manometer problems.